Alright, I'm making this video as a request from a friend, but I think he's already figured it out because I am a master procrastinator, but let's just get right into it. A matrix is a box of numbers. Here, matrix A is a 2 by 3 because it has 2 rows and 3 columns. Matrix B is a 3 by 1 because it has 3 rows and 1 column. The number of rows and columns determine the matrix's order. All numbers in a matrix are called elements, and they can really be anything, but let's keep it simple and just fill these two with simple numbers. So here's matrix A and matrix B. To add matrices together, the orders must be the exact same, so a 2 by 3 can only be added or subtracted by another 2 by 3. Other than that, simply take each element and add or subtract from the corresponding element. For example, the element in the first row second column of the first matrix will be added or subtracted to the element of the first row second column in the second matrix. Because in this example, we're adding the same matrix to itself, we are basically calculating A2, which just shows us how we can multiply matrices. Simply multiply each element by the number we're multiplying for. For example, A3 would multiply each element by 3, and that's it. It gets more complicated as soon as we try to multiply two different matrices together, which is where most of the useful applications come from. Firstly, you must note that the order of your multiplication is very important. A times B is not the same as B times A. We'll do both in this video. To start, the columns from the first matrix should match the number of rows in the second matrix. The two numbers in the center should match, and the outer numbers don't have to. The resulting matrix will be the two numbers on the outside, i.e. the number of rows from the first matrix and the number of columns from the second matrix. AB in this case will result in a 2 by 1 matrix. In BA's case, the columns don't match the rows, so BA cannot be multiplied. BA is not real. Now, matrix AB takes all elements in the first row of A and multiplies them by all elements in the first column of B. So add all the products, so 1 times 6 plus 3 times 4 plus 5 times 2, then the next row of 7 times 6, 9 times 4, 11 by 2. And then we get matrix AB. If B has more columns, then we repeat by adding the sums in the new columns, like this. That's basically it, folks, but I want to go into more detail on exactly how they are used. But they're used in so many different ways that I'm just going to do one example, 2D computer graphics, because that is literally the easiest to show. Let's say we have a square with the following coordinates of 1, 1, 1, negative 1, negative 1, negative 1, and negative 1, 1. Then we take each line of the square, a vector, which will be a 2 by 2 matrix. Now we can change the position, size, or rotation of this square by changing the position, size, or rotation of each vector. We do this by using a change matrix, which we'll call M. The matrix elements in the change matrix control how it affects the end result of each vector. For example, if we wanted to rotate a vector, we could use this matrix. This is a counterclockwise rotation matrix, and applying it to each one of our 4 vectors gives us a 90-degree counterclockwise rotation. By multiplying the square's original coordinates with the transformation matrix, we get new coordinates. So we end up with new coordinates for each point and each vector, thereby having fully transformed the square. There are other ways of doing this, and more complicated ways. In brief, matrices just refer to a large set of numbers, and it's easier for humans and computers to refer to a set of data instead of having to go to each individual point and then affect them individually. Instead, we can just refer to a matrix that is a representation of a square or even a 3D shape or whatever you want it to do with all these different examples, and then modify it accordingly using multiplication or addition. But that's basically it. Thanks for watching. Like and subscribe. Bye-bye.